Hi, I'm Alieska, and I'm going to be talking about electron distribution in atoms. So for shell number 1, the subshell is going to be S, and an S subshell can hold 2 electrons. So you will have a total electron capacity of 2 electrons in shell 1. In shell 2, you have subshells S and P. S again will hold 2 electrons, and P will hold 6, for a total of 8 electrons in shell 2. In shell 3, you're going to have S, P, and D. S again will hold 2, P will hold 6, and D will hold 10, for a total of 18 electrons in shell 3. And then in shell 4, you'll have S, P, D, and F subshells, which will hold 2, 6, 10, and 14 electrons, for a total capacity of 32 electrons in shell 4. Okay, so I'm going to be answering questions 11 through 13 on packet number 2. So 11 is how many electrons can occupy the 4s subshell. So all you really have to do is, here's 4, S holds 2, and S will always hold 2. If you want a visual, this is the S block, so there's always going to be 2 in the S subshell. Over here, this is the P block, so these are going to hold 6. These are the D block elements, which hold 10, and then down here is the F block, which hold 14. So question number 12 is how many electrons can occupy the 4D subshell. D is always going to hold 10, or you can just look at subshell D, which holds these transition metals, which are 10 going across. Then question number 13, what is the maximum number of electrons that can occupy the 4f orbitals, which F14, or just look down and count across these elements right here. They'll be 14 because they're the F block.
Hello everybody, I'm Jason Jimenez. Today we're going to do an example from packet 2, number 16. What is the electron configuration of sulfur? Here we have our periodic table. We're going to start with period 1, which is our S block group. Goes all the way to helium. Then we're going to go to period 2. There's 2 balanced electrons here, so this will be 2s2. Then we're going to go to the P block group, which has 6 balanced electrons, so you're going to have 2p6. Go back to period number 3, 2 balanced electrons, so 3s2, and look, we're looking for sulfur, so we go back to P, and you go 3, P1, 2, 3, 4, so we got 3p4, and that's how you find your sulfur. And when we write it down, we start 1s2, 2s2, 2p6, 3s2, and then 3s4.
P4.
Oh, my mistake.
There we go.
3p4.